Hi everyone, my name is Lucine Avanesian, and today I'll be presenting my work on the modeling of field-mediated formation of trifluorinated neopentane conducted under the supervision of Dr. Fedor Naumkin at Ontario Tech University. This research investigates the chemical pathways for the formation of trifluorinated neopentane using computational modeling with NWChem software and Chemcraft. The goal of the research was to observe differences in formation of carbon-carbon bonding with and without the assistance of the sodium ion. This will allow for further investigation of cheaper catalysts such as sodium in carbon-carbon bond formation rather than expensive catalysts such as palladium. On the left-hand side of the slide, we're examining the reaction between tetrafluoromethane, CF4, and neopentyl radical CCH33. As shown in the energy diagram, this reaction is thermodynamically unfavorable. The formation of the CF3-CCH33F intermediate passes through a very high energy barrier of nearly 6 electron volts. Even with the intermediate formed, the final dissociation into trifluoroneopentane and a free fluorine atom is still energetically demanding. This suggests that the unassisted pathway is not practical under typical conditions. Below the diagram, we can include infrared spectra of the reactants and the intermediates. These help confirm the molecular structures along the reaction path. On the right side, we introduce a sodium-assisted pathway. In this case, CF4 reacts with sodium neopentyl or NaCCH33. The sodium atom facilitates electron transfer and significantly lowers the reaction energy barrier. You can see in the energy diagram that the reaction is now exothermic, with the final product trifluorinated neopentane and NaF sitting much lower in energy than the starting materials. The transition states are also more accessible, making this reaction feasible. Again, we show IR spectra of the key intermediates to help validate their identities computationally. This includes NaCCH3CF4 and the final CF3-CCH33NaF complex. In summary, the modeling clearly shows that the presence of sodium facilitates the formation of trifluorinated neopentane by significantly lowering the energy barrier height. Further research will include insight into different conformers of the neopentane complex in order to determine the most thermodynamically favorable reactant complexes. The computational methods used in this research were second-order perturbation theory, following Hartree-Fock, and optimization of geometry to minimize energies. Thank you for listening, and thank you to Professor Dr. Fedor Naumkin for supporting this research.